Hi, and welcome to part 4 of our series of videos that are all about producing a screw jack. I'm not going to say where we're going to get by the end of this video because every time that I do, well, I'm wrong, so why do it? But I will state sequence by sequence what we're going to be doing so that you can understand where we're going. But before that, I'd like to answer a few questions. First thing, well, is this small Atlas lathe. A lot of questions about it. There's really nothing special to be said about this lathe. Atlas produced these lathes for many, many years, and they're great home shop lathes because they're relatively large but quite light. So they're not made to hog work and take huge cuts, but you can get away with quite a bit here because it still has a good length of bed, even though it's quite a light machine. A lot of questions about the red machine. By the way, this model of lathe was sold by Sears for years and years and years. The red color. Well, why red? Because I hate drab machine colors. I mean, I spent my life in shops and quite often quite depressing, dirty places. It doesn't have to be that way. A shop can be nice, full of life, full of color, and a clean and nice place to work in. That's what shops should be. So I painted this red, not because I just felt like it. I had to paint it a little bit because this is a basket case, really, or a box case. I found this lathe in the back of an old barn that was slated for demolition. And I bought it from the owner for $50. It was in several boxes and I wasn't even sure all the parts were there. Well, all the parts weren't there. But it took me about a year to get things all back together and running. And the other thing is, how old is it? I don't know. I do know it's older than I am. And I'm guessing from the catalogs that I've seen that this one dates from around the early 50s. So I'm a late 50s kind of guy, so this is a little older than I am. The other thing that I received many questions about was, well, the wires for the 3-wire method of measuring screw threads. Now, this is a wire set and we've seen this all before, but what we haven't seen is how to hold them properly. A lot of people saw what I was doing and said, how does it work for you? I keep dropping them. I have a hard time. I'm all thumbs. Well, it's a technique, and like anything else, you have to learn it and then practice it. And it's the 3-finger or 3-knuckle technique. Let's take a look at that.
First, let's take a look at the 3-finger pinch method. And this is pretty simple. I mean, we have 3 fingers pinching 3 wires, 2 at the top, 1 at the bottom against the nail. Now, I do that because I can adjust the distance by rolling the 2 wires and then sliding the single wire. I can go from small at the end to larger towards the knuckle. This is the technique that I used for measuring the head in the last video. And for my fingers, it permits to measure from about 1/4 inch to 5/8. Now, if I want a little larger, I'm going to use the side finger technique. And you can see here that I use 3 fingers at about the level of the first knuckle, holding them sideways. Even larger? Well, I move back to the second set of knuckles. And in this case, I'm good almost up to 1 inch in diameter. Remember that the size of your fingers, well, will have an effect on the thread dimensions that you can measure.
And that's how you hold the 3 wires. You're going to have to practice that. But one thing's for sure, if you have difficulty with those techniques or that technique, well, you can always use an eraser, poke them into an eraser to stabilize them, or a piece of Play-Doh, or even some styrofoam. It's all good. One thing's for sure though, is you don't want to lose them. So as soon as you're done using them, put them back in their place. And if you should drop one while you're working, well, if they get into your chip pan, well, they're almost impossible to find. So you want to put some kind of secondary tray down, something like this, and that will help you because obviously it'll make them a lot easier to find. So in our first setup, and we're going to be working on the body of the screw jack, so the central part, if you will, we're going to set the part up in our 3-jaw chuck, holding it as deeply as possible, but leaving about a 1/2 inch extension from the end of the jaws. We're doing that because we're going to be turning a diameter. Now this diameter is not on the print, it's a diameter that I'm going to produce, an intermediary diameter that I'm going to produce to help me with my next setup, the next time I set this part up. So just turn a small diameter, its dimension is not important as long as it's not smaller than the final diameter that I'm going to produce eventually on the part. That being said, I'm going to produce that small diameter, then I'm going to surface, center drill, tap drill, and tap that 5/8 left-hand thread. Once that is done, well, it is not time to remove this part from the chuck because we're going to move on to the machining of the head. We're going to finish the second end of the head using this as a fixture, and if I want things to maintain their concentricity, well, it's not time to move this part. So once we get to that point, well, we'll come back for the explanations of the next sequence, which will be finishing the tapered end of that head. So before we start though, remember safety glasses. It is crucially important. So let's go get our safety glasses on, head over to the lathe, and start machining. There, our internal thread is complete. Now we completed the external thread in the last video, and as mentioned, we're going to use this part semi-finished without removing it from the lathe, because everything's concentric here. We're going to use this part as a fixture to finish this part that we had started in our last video. What are we going to do? Well, we're going to tighten this down into that part, get it good and tight. Then we're going to surface the end of the piece down to its overall finished length. We can do that easily because we scribed the line showing the overall length of this part during the last video. So we're going to surface down to that line. Then we're going to drill the hole for the pivot and for the screw on the pivot. So we're going to drill a 1/2 inch hole to a very specific depth, and then we're going to drill a 1/4 inch hole. Yes, we're going to drill the large hole first and the small hole second. We don't want the end of the 1/2 inch drill to meet air as it cuts, so it's better to start with the 1/2 inch and then go in with the 1/4 for what's left of depth. So once that's done, well, we're going to cut the taper on the end of the head of this project. And then all that will be left to do with this setup is to roll the edge on this part to hold the ball in place. Now, hold it. We want the ball to be prisoner in the head, but we want it to be able to move just slightly. So let's take a look at those operations. Now, you may have noticed that I was turning clockwise and that I was cutting on the back side of the part. There's a reason for that. This part that I'm cutting is left-handed as far as the thread goes. And that means that if I turn in the normal counterclockwise direction and I cut at the front of the part, well, it could be possible to unscrew the part. And obviously, if that part came loose and started to unscrew, well, mayhem would ensue. So what am I doing? Well, I'm turning clockwise and I'm cutting on the back. That's also important because this is a hex, and as you're cutting, especially in your first few cuts, heavily into the hexagon, well, it acts a bit like an impact wrench. Now, 6 of one, half a dozen of the other. In my case, with this lathe, the thread spindle, because my chuck is held on with a threaded spindle, is right-handed. So I lose one way or the other. One of the threads isn't oriented properly. So make sure that your chuck is really nice and tight. But turning clockwise isn't an option when we start drilling, because these are right-hand helix drill bits, and obviously the part is going to have to be turning counterclockwise to use them. Well, we do have an option. You can get left-handed helix twist drills, but that's not going to happen. This is a home shop. We're not going to spend all that money for one small hole. No, we're going to use our 1/2 inch drill with our normal helix, but what we're going to do for safety to ensure that we don't unscrew the part as we're drilling the hole, well, is we're going to fix the tailstock a little more lightly than we normally would. I'm not saying to set it up loosely, I'm just saying to tighten it down a little less. And that means that if the part starts to unscrew, well, the tailstock will have a little bit of give in it. That, however, causes trouble with measurement, because if the tailstock could move, and it probably will because this is a 1/2 inch drill, I'm going to be pushing quite hard on it, well, I can't really rely on the scale of the tailstock to measure my depth. So what I'm going to have to do is the cut measure technique. I'm going to cut measure until I get my accurate depth. Now, my 1/2 inch hole has a depth of 220 thousandths of an inch and a tolerance of plus or minus 5 thou. The 1/4 inch hole that will follow has a depth of 480 thousandths of an inch and a tolerance of plus or minus 10 thousandths of an inch. So the 1/2 inch hole is a lot more accurate as far as depth goes than the 1/4 inch hole will be. So we're going to have to be a little touchy with our measuring here. Now, when you have a dimension on a print like the 220 thousandths of an inch depth, well, that is the 1/2 inch diameter portion of the hole. It doesn't include the V at the bottom here. So that means when you measure, well, with your dial caliper or your caliper's depth measurement end, you're going to want to hook just that little edge between the parallel side of the hole and the beginning of the taper at the end of the drilled hole. Now that the holes are drilled, I can set up my compound rest to 135 degrees in relation to my longitudinal axis, or 45 degrees in relation to my cross light axis, whichever you prefer to use. It's the same thing. And I'm going to come and cut that taper on the end of this head. Now, I'm going to cut till where? Well, I want the taper to come close to that 1/2 inch hole that I've just produced, but not right up to it. I don't want a feather edge. I want something that I can roll that's going to give me a nice clean edge. There, the ball fits. So now we can roll the edge. No, we can't roll the edge of nothing now because we haven't heat treated the ball yet. So let's do that. So we want to heat treat our ball. Now that sounds pretty dangerous, or at least injurious, but we're talking about the ball for this project. And well, it's a steel ball. Heat treatment isn't a very complex operation to perform. What is difficult or complex with heat treatments, well, is the knowledge required to get you to the point where you can actually produce or perform the heat treatment. Now, if you don't know or understand heat treatment, or this may be the first time you hear about it, hardening steels, tempering steels, annealing steels. If you don't know how to recognize what type of steel you have, if you want to know how to perform tests to do so, well, here's a series of videos that can help you with that. And I strongly suggest that if you want to perform heat treatments, that you understand the basics, and these videos will give you those basics. So take some time to head over and take a look at them. Now, they're easy to find on my website, THATLAZYMACHINIST.com, but if you don't want to go on my website, and that's fine, well, you can head over to Google or any search engine, but I prefer Google, and type in That Lazy Machinist, all in one word, and any one of these titles, and you'll hit that video or hit on that video pretty quickly. It'll probably be the first or second one that appears. So why don't I do links? Well, if I change anything in a video somewhere down the line, the links don't work anymore. So I find that searching or going to my website really is the best way. But we want to heat treat our ball. So what do we need? Well, we need our ball, and I have it here. And this ball is a 4140 alloy steel. So it can be hardened. It's a medium carbon steel. It can be hardened to about 54, 55 Rockwell. And once hardened, well, I'm going to anneal it, bring it back, temper it, I should say, and bring it back to somewhere around, maybe 45 to 48 Rockwell, something like that. Now, this is an oil quenching steel. I don't have any quenching oil in my home shop here. It's not something I keep kicking around. But I do have a lot of water. And you can quench an oil quenching steel in water, but you can't quench a water quenching steel in oil. Remember, go check out the videos. It'll help you to understand. Now, why don't we quench in water for everything? Well, if I pay for an oil quenching steel, it's because I want to be able to harden it and cool it down slowly at the same time. That's what oil will give me to avoid cracking and deformation. But between you and me, this spherical shape is very stable. There's no internal corners on this part. I am not worried about cracking because of its shape and because of its finish. It's highly polished. And that means that there's very few areas, or there are no areas where a stress crack can start. So I'm going to quench it in water, and I'm not worried about cracking, and then I'm going to polish it up, and then I'm going to come back and draw it back, okay, or temper it slightly. I'm going to bring it to a nice purple or dark blue color. We'll take a look at that. But it has to be polished and clean before we do that. No oil on the part whatsoever. Polishing is a problem here. Well, not really. The lathe is busy. Remember, our parts are mounted in it, and I don't want to take them out. I want to keep everything nice and true. But I do have a drill press, and this part can easily be polished in the drill press. So that's what we'll do. Now, I also need a heat source, and I have one right here, propane torch. Now, I can hear you say, well, propane torch isn't hot enough. Be careful. There's two things with heat. There's temperature, and then there's amount of heat or energy at your disposition. Disposal, I should say. Disposition is the French way. Anyways, you know what I mean. So, what do I mean by that? Heat and amount of energy. Well, temperature, propane gives you a high enough temperature to harden steel, no problem whatsoever. what a small propane torch can give you is a volume of heat. So if you're working on a small part like this torch is more than powerful enough to do it. If you want to heat treat a larger part, like this is the same material as the ball here, but it's a much more massive part, well, you're going to need something that packs more punch than this torch. Not because it's not hot enough, just because it's not strong enough. So you could use several torches or a bigger burner type thing, or you could go to an oxyacetylene or something of that sort. That being said, you want to be able to hold the part without coming close to it, because it is going to get up to about 1550 degrees. And I don't have to tell you that you don't want your fingers to come in contact with that. So make sure you have a way of holding it safely. So let's come in a little closer and take a look at this operation, starting with the hardening or the heating up and the quenching. So here's the forming tool I'm going to use. It's a regular tool blank, but it isn't a cutting tool because I've rounded the top edge off so that it's nice and smooth and will not cut. I want this tool to rub because I'm going to form that lip. I'm going to push it inwards very slowly and progressively so that the ball becomes prisoner of the hole in the head of this project. Now, I don't want the ball to be tight, so I'm going to round the lip over just enough to stop the ball from falling out. I don't want to lose the ball all the time. No, I want it to stay in there, but I want it to be loose so that it can pivot. And that's what that set screw, or in this case the shortened screw that's in the ball, is for. It's so that it can pivot without turning completely around. And that will keep the flat pointing upward even though I have a certain amount of degrees of adjustment on that ball. That being said, I'm going to put some grease in the hole before I push the ball into it, and that will help lubricate the ball for pretty well the life of the tool, but also it will help to hold the ball in there while I'm forming. So let's set up and take a look at that. So now we can pull the head from the body. It's complete, not the body, the head I mean. And then I can pull the body out a little further, because the next operation is going to be threading that first end of the body of this project. We're going to cut that external thread, complete that end of the part, but we're not going to cut the back side of the body. We're going to then move on to the base and turn the internal thread on the base to before using that base as a fixture to come and complete the body. So we're going to be doing this as we did the last part. Start one, not finish it, start the other, use it as a base or a fixture to finish the one that was started before. So let's take all this apart and move on to our next operations, but that'll be for next time. For now, well, have fun, be safe, and happy machining.